Hello, ladies and gentlemen, Root Beer here, and I'm going to be starting another University of Waterloo math contest. This time it's going to be the Galois contest from 2016. Now, as you can see here, it is a grade 10 level contest. Waterloo has two contests aimed specifically at grade 10. The Galois paper, which we're going to do, which is a written contest, and the Cayley paper, which is a multiple choice contest. Now, you can get a copy of this contest by clicking the very first link in the description. There are only 4 questions. 1, 2, 3, 4. That's it. So if you want to, pause and try it out for yourself, get a copy, download a copy, print it, or, just read it on a tablet or something. Give yourself just an hour and 15 minutes to give these questions a try. Or at least, try each question before watching the corresponding video. I will be doing one question per video. And that way you can really gauge how well you might do on a question, where you get stuck, where you might need to improve, perhaps for this year's Galois. Okay? Now, there's no bias in marks. Each question is worth 10 marks, so you get just as many for doing the last question, question 4, which should be the hardest one, as you get for doing question number 1, which should be the easiest one. And we're going to do question number 1 in this video, so let's dive right in here to question number 1. Liza has a row of buckets. The first bucket contains 17 green discs and 7 red discs. Each bucket after the first contains 1 more green disc and 3 more red than the previous bucket. Alright, and then we've got these nice little symbols beside each part of the question. The light bulbs just require a final answer, but as I already hinted in the intro, this is a written contest, so when you see the hand with pen to paper, you do need to provide a full solution, justify everything you're doing, show your calculations, explain your reasoning. If you use the Pythagorean theorem, say you're using the Pythagorean theorem, that sort of a thing. Okay, and we'll get into C in just a little bit. Now for A, we just want to know which bucket contains 16 red discs. Well, we know how many red discs we start, and we know how the red discs grow, so it's not too bad to do a quick calculation. So we might keep track. Our first bucket has 7 red. Then the next bucket will have 3 more. So 10 red in the second bucket. And we just keep going up. We get 13 red, and then finally, in the fourth bucket, 3 more. We get 16 red. So the answer they're looking for would be something like fourth bucket. And you would just put that in the little booklet that is provided the day of the contest. But we have actually shown our reasoning. We've shown our calculations of the other buckets. Just in case we had a typo, we accidentally put fifth bucket or something, we might still be able to get some part marks, and that's always good. Alright, B. In which bucket is the number of red discs equal to the number of green discs? So they don't start out equal, okay? But we know how the green discs grow, and we know how the red discs grow. So let's, we could give this bucket a name. There's a couple ways I can see to do this. One thing I can do, which I think is probably the more clever, we start with 10 more green discs than red discs. Now, every time we move over a bucket, we gain 1 more red, we gain 1 more green, but we gain 3 more red. So on balance, every time the red discs are catching up by 2. How much do they need to catch up? Well, the difference is 10, so it should be the fifth bucket. That's what I would guess. Okay, fifth or sixth bucket, something like that. Okay, but we can actually do a calculation. We might say something like let B be that bucket. Okay. Now, after the first bucket, we add in 3 red and 1 green each time. So, from the first bucket, which had 17 green and 7 red, we have added 1 green, B minus 1 times. In order to go from the first bucket to the second bucket, we've added in 3 reds and 1 green. To go to the third bucket, you've actually added in 2 greens, or you've added 2 greens, 1 green has been added 2 times. Okay, so we do have to be careful with this B minus 1. And we've added in 3 red, B minus 1 times. That's why the fourth bucket has 7 reds plus 4 minus 1 times 3 reds. 4 minus 1 is 3, times 3 is 9. 7 reds plus 9 reds is the 16 reds we've got. So the Beeth bucket has 17 plus B minus 1 greens. And that's got to be equal to the same number, to the number of reds, which is 7 plus 3 times B minus 1 reds. Well, we've got a single equation in B. We can work this out. So we get 16 plus B when we clean up the left-hand side. And we get 4 plus 3B when we clean up the right-hand side. Okay. And if we divide by 2, we see that B is 6th. The 6th bucket, we've gone over 5 steps, so the other reasoning I provided would still work. But we can just say, 6th bucket. And that's what they're looking for. If you can do this sort of thing in your head, if you can work it out without having to write any of the work down, it's a light bulb question, that's fine. But you may want to get in the habit of just writing down a little bit of your calculation in case you don't have it completely right. And you don't have everything that they're looking for. Okay, so we're going to finish off question number 1 now with C part. We are going to write, mostly incomplete sentences. I try to have my solutions be roughly what you would want to show on an actual contest. What have we got for C? There is a bucket in which the number of red discs is twice the number of green discs. In total, how many discs are in this bucket? Okay. So, well, I think it might be easiest to first find that bucket. Okay. So I'll say something like, as noted in part B, the Beeth bucket has, 16 plus B greens and 4 plus 3B reds. Now, instead of having the greens equal the reds, we want the reds to be twice the number of greens. So there's the number of greens, multiply that by 2, and that should be equal to the reds. Alright, well, we can simplify this. 32 plus 2B should be equal to 4 plus 3B. And 32 minus 4 is 28, and that should be equal to, 3B minus 2B is just 1B. So the 28th bucket is the one we're looking for. So the 28th bucket, we might say, has the desired ratio, but we weren't asked what bucket. We were asked how many discs are in this bucket. Well, we know how many greens, so we can say the number, and we know the number of reds, all in terms of this 28. So the number of discs present is, the number of greens plus the number of reds. So that should be 16 plus B, which is 28, plus 4 plus 3 times B, which is 28 as well. So we can get 20 plus 4 times 28. In fact, one thing you could have done from these two formulas is you could have said, well, any bucket, the Beeth bucket has 20 plus 4B discs in it, period. Okay, but we can simplify this now. 4 times 28 is going to be 2, k to the 3, so it should be 112. Okay, and we add that up, 132. That's the number of discs in the 28th bucket, and that's the one we're looking for. Okay, but we don't just care about putting our answer 132. We've explained how we got the 28th bucket. We've explained how we got the number of discs, so we should be getting full marks from there. Okay, so that was question number 1. If you want to give question number 2 a try, we'll be looking at that in the next video, and so on. So thank you for joining me, and I'll see you for more of our Galois paper in the next video.